Water has emerged as one of the primary environmental concerns for the 21st century. Water is the common name applied to the liquid form of hydrogen and oxygen compound H2O. Pure water is an odorless, tasteless, clear liquid. Water is one of the nature's most important gifts to mankind. Essential to life, a person's survival depends on drinking water. Water is one of the most essential elements for good health. It is necessary for the digestion and absorption of food. In fact, human body is made up of approximately 70% water. Water covers approximately 70.9% of the Earth's surface and is vital for all known forms of life. On Earth, 96.5% of the planet's water is found in oceans, 1.7% in groundwater, 1.7% in glaciers and the ice caps of Antarctica and Greenland. A small fraction in other large water bodies and 0.001% in the air as vapor, clouds and precipitation. Only 2.5% of the Earth's water is fresh water and 98.8% of that water is in ice and groundwater. Less than 0.3% of all fresh water is in rivers, lakes and the atmosphere, and an even smaller amount of the Earth's fresh water is contained within biological bodies and manufactured products. Many parts of the world are currently facing water shortages, and many more are likely to face water crisis in the future, while others must face severe water pollution problems. There is an alarming lack of long-term policies to target problems related with water quality and water management. The consequences are bleak social, economic and political instability, leading in the worst-case scenario to violence over dwindling water resources. Immediate action is needed to overcome water problems. Water management is the activity of planning, developing, distributing and managing the optimum use of water resources. In an ideal world, water management planning pays attention to all the competing demands for water and seeks to allocate water on an equitable basis to satisfy all uses and demands. This is rarely possible in practice. Watershed Management. Rivers originate in streams that flow down mountains and hill slopes. A group of small streams flow down hillsides to meet large streams in the valley, which form the tributaries of major rivers. The management of a single unit of land with its water drainage system is called watershed management.
A watershed is an area which actually divides the flow of water. Two watersheds are divided by one ridge, and in between a watershed there are a number of valleys. So the concept of ridge to valley water treatment is actually the whole essence of the watershed management. The watershed management not only involves the regulating the flow of water or controlling the flow of water, but at the same time the treatment of the earth's surface in such a way that the velocity of water can be sufficiently controlled for our desired use. Say for example, if the slope of the terrain is very high, in that case you can actually construct some structures which reduce the velocity of water and in the process stop the soil erosion. This helps in many ways. Number one, it reduces the soil erosion, thereby maintaining a good quality of and quantity of soil on the slopes. Number 2, it actually increases the soil moisture at the same time, which actually helps in rejuvenating the streams. This is the sole essence of watershed, in which we take advantage of the earth's surface and the structures are built accordingly to control the flow of water.
It is a technique that has several components. This includes soil and water management and developing vegetation. The natural drainage pattern of a watershed unit, if managed properly, can bring about local prosperity by providing a year-round supply of water, thereby improving the quality of life in the area. Since it provides water throughout the year, this improves health in the community as clean water becomes available. Watershed management enhances the growth of agriculture crops and even makes it possible to grow more than one crop in a year in dry areas. Watershed management begins by taking control of a degraded site through local participation. People must appreciate the need to improve the availability of water both in quantity and quality for their own area. Once this is adequately demonstrated, the community begins to understand the project and people begin to work together to promote good watershed management. The first technical step is to take appropriate soil conservation measures. This is done by constructing a series of long trenches and mounds along the contours of the hill to hold the rainwater and allow it to percolate into the ground. This ensures that underground stores of water are fully recharged. This is enhanced by growing grasses and shrubs and planting trees, which can hold the soil and prevent it from being washed away in the monsoon. However, local grass cover can only increase if free grazing of domestic animals is regulated or replaced by stall feeding. Groundwater management. Groundwater is the major source of drinking water in both urban and rural India. Besides, it is an important source of water for the agricultural and the industrial sector. In 2000, about 50% of the existing groundwater was utilized. Being an important and integral part of the hydrological cycle, its availability depends on the rainfall and recharge conditions. Till recently, it has been considered a dependable source of uncontaminated water. The demand for water has increased over the years, and this has led to water scarcity in many parts of the world. The situation is aggravated by the problem of water pollution or contamination. India is heading towards a freshwater crisis, mainly due to improper management of water resources and environmental degradation. This has led to a lack of access to safe water supply to millions of people. Freshwater crisis is already evident in many parts of India, varying in scale and intensity depending mainly on the time of the year.
Groundwater is contaminated due to external forces as well as geogenic sources. Geogenic source contamination is something when some ingredients of the rocks itself include or induce some groundwater pollutants. That also comes into groundwater management strategy, that whatever water which is free of the impurities, if it is available to us, how to use it. If the groundwater is contaminated with some geogenic impurities, how to make it useful for us. All that includes in fact groundwater management.
Groundwater systems are for meeting the ever-increasing use of water. The proper design and management of these systems should, therefore, be a very important matter of concern.
in one particular site we might be having enough groundwater to cater to a particular village or a particular town, but the nearby village or nearby town may not be having any water. So in totality you have to take into the consideration that this groundwater reserve, which is available in one particular village or a town, is a common property of both the villages or a town, because the other village or the other town is not having any groundwater reserves. This is what we call groundwater management. This groundwater management, once the groundwater resources are established, after that the withdrawal of groundwater is monitored, and then we come to a certain calculation that how much groundwater is needed, how much is to be conserved, how much is to be kept for the further use, how much is to be allocated for what use. Groundwater can be put to many use, in fact. It's not only for drinking water, it can be used for agriculture, it can be used for industry, and so on and so forth.
So as to ensure that there is enough water of adequate quality to satisfy demand. Several management programs have been purposed to protect, preserve and restore groundwater bodies. Rainwater Conservation Management. Our ancient religious texts and epics give a good insight into the water storage and conservation systems that prevailed in those days. Over the years, rising population, growing industrialization and expanding agriculture have pushed up the demand for water. Efforts have been made to collect water by building dams and reservoirs and digging wells. The idea of groundwater recharging by harvesting rainwater is gaining importance in many cities. Rainwater harvesting is accumulating and storing the rainwater for reuse before it reaches the aquifer. It has been used to provide drinking water, water for livestock, water for irrigation, as well as other typical uses. Rainwater collected from the roofs of houses and local institutions can make an important contribution to the availability of drinking water. It can supplement the subsoil water level and increase urban greenery. Water collected from the ground, sometimes from areas that are especially prepared for this purpose, is called stormwater harvesting. In some cases, rainwater may be the only available or economical water source. Rainwater harvesting systems can be simple to construct from inexpensive local materials and are potentially successful in most habitable locations. Roof rainwater may not be potable and may require treatment before consumption. As rainwater rushes from roofs, it may carry pollutants such as mercury from coal-burning buildings. Although some rooftop materials may produce rainwater that would be harmful to human health as drinking water, it can be useful in flushing toilets, washing clothes, watering the garden, and washing cars. These uses alone halve the amount of water used by a typical home.
Rainwater conservation is one of the techniques by which we try to enrich groundwater as well as enrich the surface water sources. Rain is a very important part of our hydrological cycle. Whatever water is available on the planet of Earth, it actually moves in a cycle which is called water cycle. Water cycle is a very simple cycle in which seawater first evaporates, forms clouds, comes back to the earth's surface as rains, trickles down the surface of the earth, flows and then gets back into the sea. In the process, the water comes into contact with the earth. Water sometimes gets frozen and forms glaciers. Water sometimes percolates below the ground and becomes groundwater. Sometimes it is entrapped between the soil and the groundwater, soil and the bedrock, and becomes subsoil water. All these are the change of various forms of water from one form to other, depending on the physical process through which it is passing through.
Agriculture water management. Water is one of the most important inputs essential for the production of crops. Plants need it continuously during their life and in huge quantities. It profoundly influences photosynthesis, respiration, absorption, translocation, and utilization of mineral nutrients and cell division, besides some other processes. Shortage and excess of water affects the growth and development of a plant directly and consequently its yield and quality. Rainwater is the cheapest source of natural water supply for crop plants. In India, however, rainwater is notoriously capricious, causing floods and droughts alternately. Its frequency, distribution, and amount are not in accordance with the needs of the crops. Artificial water supply through irrigation on the one hand and removal of excess water through drainage on the other, therefore, becomes imperative if the crops are to be raised successfully.
There are ways and means, in fact, with the advent of technology, with the advent of new systems we have. Now we are going in for water saving devices like drip irrigation or sprinklers. The better water use efficiency actually results in saving of lot of water, which can be used for other purposes or which can be used for the areas in which the irrigation cannot reach. These devices like sprinklers and your drip irrigation systems save enough water for the water to be used judiciously. This is what actually is agriculture water management. You have to very carefully understand the implication if there is no water available for groundwater, not because the groundwater is not available, but because of the competitive use. The competitive use is when the water is being put to use by the industries or by the nearby cities, the same water which is deemed to be used for agriculture.
Water management in India thus comprises irrigation or drainage or both, depending considerably on the environmental conditions, soil, crops, and climate. It is a situation-oriented entity. Water affects the performance of crops not only directly but also indirectly by influencing the availability of other nutrients, the timing of cultural operations, etc. Water and other production inputs interact with one another. In proper combinations, the crop yields can be boosted manifold under irrigated agriculture. Water is a costly input when canals are used as the source of supply. The construction of dams and reservoirs, the conveyance of water from storage points to the fields, the operation and maintenance of canal systems involve huge expenses. The misuse of water leads to the problems of waterlogging, salt imbalance, etc., thus rendering agricultural lands unproductive. Hence, a proper appreciation of the relationship among soils, crops, climate, and water resources for maximum crop production is essential. Water management practices with regard to quality and domestic utilization. Water quality is a term used to describe the chemical, physical, and biological characteristics of water, usually with respect to its suitability for a particular purpose. Although scientific measurements are used to define water's quality, it's not a simple thing to say that this water is good or this water is bad. When the average person asks about water quality, they probably want to know if the water is good enough to use at home or to serve, or if the quality of our natural waters are suitable for aquatic plants and animals. Standards and guidelines are established to protect water for designated use, such as drinking, recreation, agricultural irrigation, or protection and maintenance of aquatic life.
We have to very judiciously select and mix the various water use which any water available to us can be put to use. In fact, whatever water is available to us should be properly analyzed and seen that whether this water which is unfit for one particular use, can it be fit for another use? Can it be fit for another use with some minimal treatment, so that we can put all the water we have to some use.
Standards for drinking water quality ensure that public drinking water supplies are as safe as possible. In India, the Ministry of Water Resources and the states are responsible for establishing the standards for constituents in water that have been shown to pose a risk to human health. Water used for drinking, cooking, washing and cleaning contributes to the welfare of all household members. In rural communities, men may be responsible for the construction and maintenance of domestic water infrastructure, while women ensure that water is permanently available in the house, although other patterns have been reported as well. When the government or private vendors sell domestic water for cash, either men or women or both may be responsible for that household expenditure. In any case, water supplies projects become considerably more effective if men's and women's complementary intra-household roles and perspectives are incorporated in project design and implementation up to the decision-making level. Water management and industries. Water pollution is also caused by emission of domestic or urban sewage, agricultural waste, pollutants and industrial effluents into water bodies. Nowadays, one of the main sources of water pollution is the waste material discharged by industrial units, known as industrial water pollution. Waste materials like acids, alkalis, toxic metals, oil, grease, dyes, pesticides, and even radioactive materials are poured into the water bodies by many industrial units. Some other important pollutants include polychlorinated biphenyl compounds, lubricants, and hot water discharged by power plants. The pollutants unloaded into the water bodies usually dissolve or remain suspended in water. Sometimes they also accumulate on the bottom of the water bodies. Another important pollutant that can endanger marine life is the oil spilled by oil tankers. As per the estimate of the United Nations, 1.3 million barrels of oil is spilled annually into the Persian Gulf, and about 285 million gallons is spilled into the oceans every year. The industries contribute to more than half of the total water pollution. Industrial effluents contain pollutants like phosphates, mercury, lead, nitrates, sulfur, sulfuric acid, oil, and many other poisonous materials. In many countries, industrial water is not treated adequately before discharging it into rivers or lakes. This is particularly true in the case of small-scale industries that do not have sufficient capital to invest in pollution control equipment.
The treatment of the wastewater before disposing it off on the ground is very important, very crucial. Therefore, the water management practices in an industry typically involves first the source location, then the water transportation from the source to the industry, third the use of the water itself in the industry in a water efficient and user efficient manner, fourth the effluent which is generated is to be treated, the treatment is involved, and fifth, if it is to be reused or recycled, the effluent is to be processed for further parameters to be achieved. Thus, any water management for any industry or an industrial sector requires all these complex things.
Wastewater management practices. Wastewater is any water that has been adversely affected in quality by anthropogenic influence. It comprises liquid waste discharged by domestic residences, commercial properties, industry or agriculture, and can encompass a wide range of potential contaminants and concentrations. In the most common usage, it refers to the municipal wastewater that contains a broad spectrum of contaminants resulting from the mixing of wastewaters from different sources. Sewage is correctly the subset of wastewater that is contaminated with feces or urine, but is often used to mean any wastewater. Sewage includes domestic, municipal or industrial liquid waste products disposed of usually via a pipe or a sewer or similar structure, sometimes in a cesspool emptier.
The industrial effluents which are being generated out of industry, they are to be put to reuse or recycle. They are to be put to reuse and recycle with minimum treatment for their gardening needs, for their horticulture needs, for their plantation needs. They can do it. The municipal waste which is generating out of the cities can be used with some proper treatment for the municipal plantations, for the plantations the roadsides, for the local gardens or the small house gardens we have. So all these techniques which are involving wastewater use are called wastewater management practices. This wastewater management typically involves first the collection of wastewater at a particular site, then treating it, and then ultimately putting it to better use.
If the term water waste treatment is confusing to you, you might think of it as sewage treatment. Nature has an amazing ability to cope with small amounts of water wastes and pollution, but it would be overwhelmed if we didn't treat the billions of gallons of water waste and sewage produced every day before releasing it back to the environment. Treatment plants reduce pollutants in wastewater to a level nature can handle.